Hi everybody. In this video we're actually going to do the coding to hash passwords. So let's get started. So the one we're going to use, and you're free to use whichever one you want, is called Bcrypt. And when it hashes a password, in addition to kind of stuff that looks like this, just nonsense stuff, it appends a prefix so you know that it is Bcrypt, and that's 2B. So if passwords start looking like, wait a second, these hashes look pretty much the same, or they all start the same, it's because it appends a prefix. This means it's Bcrypt. And it also appends what's called the cost parameter, and that means how hashing is done. It's done in rounds, and these rounds are kind of expensive to hash a password, so the more rounds there are, the slower the algorithm runs. And that's, oddly enough, a good thing when hashing passwords, because if someone's trying to brute force your password, if it takes them longer, if it takes them 1,000 times longer, that's, much better, because it takes that much longer. If it's every password's 1,000 times longer, it's going to take, instead of like a couple minutes to decipher a password, it's going to take perhaps years to decipher a password. So this is, and what's good with Bcrypt is that we can scale it. So as machines get faster, we can just change this one parameter and keep up with the speed of hackers. And then what happens is there's 128 bits, the salt that is randomly generated for that particular password, so people can look at it in the clear. As I showed here before, that I was appending it at the end. This comes first, what the salt is. And again, it doesn't matter if we know the salt, it's not helping us to do the decryption. And finally, there's going to be a 184-bit hash. So that's sort of the format of when we look at stuff. That's how we're going to decipher it. All right, so let's get started here. So the first thing I'm going to do, let me clear this, is, and I'm going to start, sorry for I'm already interrupting here, but I'm going to start with this code that we've already were using before, where I was storing user one, or the user and the password in the clear, or comparing it at least. And there's kind of an example from the table. I just am printing select splat from users. You can see that I can read the word password. What we're going to try to do is hash it. That's our goal in this video. All right, so let me go back to this tab of my terminal, and let me make a directory. I'm just going to start from scratch here, called pod2, change into that directory, do my npm init, and it's going to ask all those questions again. Okay, now I'm going to install, since we're dealing with Postgres, I'm going to install that Postgres adapter. And as you may guess, I'm going to also have to install Bcrypt. All right, that looks good. And let me copy that. I don't know if I need that. I guess it doesn't hurt to start with the code we already have. So I'm going to copy from pod1 try to here. So I'm just going to start with that code. And let me open that up. All right, so now I have that. I can close, or at least hide that. All right, and so now it's going to be in try. So the first thing we need to do here, in addition, now we kind of required that Postgres library. We need to do the same thing for Bcrypt, and I'll do that. Okay, so we installed Bcrypt, and now we require it in there. And let me create a function to add a user, and I'll do that. Let's say I'll do that down here. And I'll call that function add user. We have a username and a password. And now here I can use my Bcrypt function. Oops. And it's going to take a password and hash that password. So I say password. Here's the cost function, 10. Again, the more, that's 2 to the 10, so the more, if you put 12 there, it's going to take longer to encrypt, or to hash rather, but it takes a hacker much longer if they're trying to do a brute force on your password. And I'll explain this in a second here. Let me see if that looks good. So far, so good. So what this bcrypt.hash, it's also an asynchronous function, meaning it can operate at the same, it looks like it operates at the same time as the stuff in your code. And it handles things a little differently than we've seen with promises, in that there's a callback function. So when hash is completed, it's going to execute this function. It's a little bit older method of how things like this work, how asynchronous works in JavaScript. So when it finishes hashing that password, and now the value is going to be in hash, let's say I want to, I'm going to insert something into the database, and I'm just going to pass it to, I guess I don't need to do, I'll do it this way. We know this, so I'm going to insert the username is number 1, number 2 is going to be that hashed password. Oops. So the username is here, the hash password, is hash. So the username comes in as an argument. Hash is what's returned from bcrypt.hash. All right, that looks reasonable, I think. And let me just kind of make sure it looks good. All right, and let me execute that query. I think I have code. Well, maybe I don't have the code here. All right, let me make it. I thought I had something similar. So that's going to be an async function. And I think what I'm going to do is just copy and paste this and revise what I need to revise. Okay, and I don't need query because I already have the query, and I'm not going to console log it either. All right, this probably wasn't that useful to copy it. So var response await pool query. All right, that looks good. I don't really need that either. All right, so I think that may be good. So let's take a look at it. So what I'm doing here is this add user function is going to take a username and password. Then I'm asking bcrypt hash to hash that password using a cost function of 10. And when it does finish hashing that password, because we're operating asynchronously here, it's going to call this function where the value of the hash is hash. And then I should have probably done some error protection here, but I didn't, to make sure there were no errors. And then I execute the query, insert into users, values 1, 2, and I see I made a mistake here. Lucky thing I was looking. Okay, and that looks good. And then this execute query is asynchronous, and it's waiting for that, and everything looks reasonable to me. So what I'm going to do then is let's add a few. Add user Dan with password. Let's add another user. Whoops. Well, let's compare, since I'm curious if it's the same password, what it looks like. Okay, I'll be amazed if this works, but okay, let's give it a try. So let me save it. And that did not work. Add user. All right. I'm hoping people saw that error before I did. Now that should work. Sorry for the, let me clear this. Okay, I'm getting a... Oh, okay. I think we know what's wrong there. Let's take a look back here at our billboard thing. And I never fixed, let's see, I forget my username. Grant, select, insert to... Oh no, I don't need to do that. That should be adequate, hopefully. Okay, and this is taking a little bit of time. Mainly, I'm not printing anything out, and it's taking time on those asynchronous commands here. While we're waiting, let me go back to this and then do a select on that. See if it added them. Oop. My common error here. And we see it added them. And here, as I said, that is the prefix to A. 10 is the cost function. This beginning part, I don't know where it stops, but is going to be the 128-bit salt. And then the rest is the hash. And you see that even though I forget, Dan and Enrique had the same password, they don't look anything, I'm hoping that you see, they don't look anything alike. So that's the encryption phase. So hopefully that looks fairly simple. So let me now go and do the how to check whether a password is correct. So someone wants to log in, they log in, and then we want to check whether that's correct. So let me go ahead and do that part. Let's do that down here. So I'm going to do an async function. I'm doing an async function. It depends on whether I'm awaiting or I want to await is part of my criteria for these async things. Okay, so this is the login without any added encryption. So I just, what I'm going to do is do the select. I'm going to print it out just to see what it looks like before I add any of the Bcrypt stuff. And let me comment this out. And then just do login. And see what that looks like. Let's give it a shot. Okay, and it prints out the hashed password from the database. So now let's add the Bcrypt function in. So that one is like this. So I'm going to do that here, and this is somewhat lengthy. And I'm sorry for that, but it's going to be Bcrypt, maybe. So it's going to compare a password, which in this case is password, with the encrypted password. Okay, and I just want to pause here for a second. So if I print it out, let me comment this out and explain something briefly. And I'll comment this out as well. Okay, let me do this one. Okay, so here what response rows returns is an array. There's the start of the array, there's the end of the array. And I want to get the first, it only has one thing in it. There's only one entry that matches username Dan. So the first element of the list is this. That's where zero's coming in. And I'm asking for the password field of that JSON document. So I'm just trying to decipher what response.rows0.password is for you. And that's what it is. Right? So rows is an array. This is the 0th element of the array. And this is the part of the JSON that matches password. All right, let's go back to our coding. So here, bcrypt compare compares the password and the value we get back from the database. And I'll do the rest down here. Again, it's an asynchronous function, so when that completes, when the comparison is finished, and the reason is, remember I said that this takes a fair amount of time, this bcrypt. So when the cost function is something like 12, it takes maybe 1/3 of a second or something like that. So that's an awful lot of time in what other code we can execute. All right. So when it does get done with the comparison, we can see if we get some response, then that means the passwords match. So I'm just put a comma. And because I'm not really doing a log, here's where I might, if I was doing a login, I would send something back to the browser or something. But in my small case here, I'm just going to log passwords matched. Okay. And you can guess what the else is. Okay, that looks good. Sorry, I'm just staring at if I've added everything here. That looks good, I think. I always worry that I'm not doing things right. But okay, let's see if this works for login Dan. So we get passwords match. Let's try Dan with dog. And here's the stored password. As you can see, it doesn't match that, but let me... And that didn't work. Did I save it? No, I didn't save it. That's my problem there. So this shouldn't match. Just wait till that finishes. Passwords don't match. And I guess I showed you everything. So here was the simple part. Let me scroll back up of adding the user. So here I hash. It's an asynchronous function. When the hash is returned, I insert it into the database table. And we've seen that. I've shown that here. So now everything's stored as hashes. When a person logs in, now it's not enough to compare. Before I could just say, if someone types in, I'm Ann and my password's password, I could just compare those straight off. But now I can't because everything's hashed. So now what I need to do is, where's my login thing here? So I get the hashed password from the database. I compare that hashed I use bcrypt.compare, which is comparing that hashed password to the clear password. If they match, I print they match, else I print they don't match. So that's it. You can see it's fairly easy to use. Maybe the difficulty is the asynchronous nature of everything, but that's password protection kind of in a nutshell, that we want to hash stuff, we want to make sure we salt things, and even more critical, or perhaps not more critical, but we want to use random salts. So that's it. I hope this video was helpful. Take care.